realized I should unmute myself. Hello, everyone. Good morning, good afternoon, good evening, wherever you are. Welcome to this stream today. Today we have a special guest. We have Philipp Krenn, who is a developer advocate at Elastic. He's here to talk to us about Elasticsearch's serverless option, the actual Elasticsearch one. So really excited to see this. Let me bring him up on the stage here.
Thanks a lot for having me. Yes, that's actually a very good introduction. The original Elasticsearch, and Elastic is the company behind that, and I'm happy to dive into that today. I guess I'll just share my screen and take it away.
Awesome. Yeah, glad I got it right. And also just a reminder to people watching live, feel free to ask questions. I think you mentioned that you're good with live answering as we see them.
I'm good with live answering. I actually have the chat and everything on a second screen, so maybe I'll catch that. Otherwise, please stop me. But I'm happy to jump into anything as we go along.
Cool. Yeah, if we miss anything, we can do it at the end as well. So let me bring up your slides. Awesome. I'm going to get out of your way.
Perfect. So welcome, everybody. While we talk about serverless, my talk is actually called stateless, or to do more with stateless Elasticsearch, because Elasticsearch, the search engine or data store, obviously has state, and the state is very pesky in a serverless environment. So I mostly want to talk about like that stateless nature and what that can bring you. We'll dive a bit into what and why. Since this is a show about serverless, I'm sure everybody knows this, like the different levels of what you do yourself versus what you outsource. But I'll map that to the Elastic offerings, or how you can run Elasticsearch today. And we have one for each one of those four. So the traditional on-prem is you would download the Debian or RPM package, maybe the Docker container. You do everything yourself. You own the hardware, you do the installation. If you upgrade, you need to make sure you need to upgrade every single server in the right order. You have all the control, but you also need to do everything that you want to do. Pretty much like cooking from scratch at home. Then we have what might be the take and bake, where you buy the frozen goods and just bake them up at home. We have a Kubernetes operator. So if you have Kubernetes, you can run our operator and actually let that do a lot of the hard work for you, where you basically just specify for Kubernetes that I want the cluster in this version with this size. And then later on, you can scale it up or down. You can upgrade the version, and the operator will do a lot of that operation for you. So it will know how to do a rolling upgrade, one instance at a time, and take care of more things for you. That's kind of like the take and bake example. Then we have a hosted service, which is pretty much the delivery method here. So for the delivery, you still have your own dining table and drinks. The hosted service that we have is in a UI or through Terraform, for example. You just specify what you want. You don't need to have your own Kubernetes cluster anymore. You don't need to have the hardware. We will run all of that for you, but you still need to specify what version do you want, what instance size. When you do an upgrade, you need to actually click a button or call the Terraform provider to actually do the upgrade for you. So there's still some work involved. And then what is new, what we're bringing now, is the serverless offering for Elasticsearch, where everything is being taken care of. And you basically say, I want the serverless offering for this part of the product in this region, and everything else happens for you, and you don't need to do anything about that anymore. One comment that I've sometimes been getting is like, so you take care of the data? No, you still need to bring your own, or at least connect your data. So the data is still necessary. So you, as the eating person here, is not included. And it's kind of like the same thing for your data, that you still need to bring your data, but everything else is being taken care of. And to maybe put it into a slightly more elastic perspective, is this is the same breakdown, just like for the Elastic offering, going from self-managed, where you have all the control, but you also need to do everything yourself, to the operator on Kubernetes, the hosted service, and then the serverless offering, which is much simpler, but you give up some of that control, and you can rely on Elastic doing that work for you. How that looks like, you can get Elastic Cloud from Elastic either directly from us or through the marketplace on AWS or the other major cloud providers. How the offering within that is then structured is that you have one or more organizations, and in one organization you can pick between serverless or the hosted offering, which is the traditional one. And this is what the UI looks like, but maybe let me just do that for you. So we have the interface. The top one right now is the hosted offering, and I have various clusters running in various versions here. But what I want to focus on here now is I want to create a new project. And when you create a new project, you basically pick the solution that you want. So Elasticsearch, so search or vector search is this. We also have observability, or what used to be the classic ELK for logging, but is a lot more nowadays. And we also have Elastic for security with SIEM and endpoint protection, etc. You basically pick one of the three solutions. All three will still include things like Discover and dashboards. So you always have Kibana and you always have Elasticsearch under the hood, but you have a more guided path to the problem that you're trying to solve. They will also have different pricing or billing approaches. We'll get to that a bit later. But what you basically need to do is you need to figure out, like, what am I trying to do? Am I having a search or vector search use case? Do I want observability, or is it a security use case? And then you pick the right cluster for that. And I will pick Elasticsearch here. Within Elasticsearch, I need to give it a name. My serverless demo, let's say. You have the option between a general purpose like classic search use case that is optimized for, an optimized version for vector search, or soon we'll also have a time series option here. I'll stick to the general purpose one for now. One of the options you have down here is you can pick your cloud provider. Right now, this is not GA yet, and we only support AWS, but we'll have the other cloud providers soon as well. So AWS is for the serverless offering, the only option. The hosted one has all the cloud providers already. And then right now, this will also increase over time. We support 4 regions. So we have 2 in North America, 1 in Europe, and 1 in APJ. I'll just stick to, well, let's go with Oregon. And that's really everything that you need to do. And then you can click Create Project, and it will start spinning in the background. This will right now still take a few minutes. We're working on making that faster as well, but this is spinning up the right resources for us. And I'll let this go and finish and return to my slides in the meantime. So how does this work? I've been saying that state is kind of this pesky or annoying thing that you need to manage. That is very true for any serverless offering that is a data store. And I have the classic, existing is maybe an overstatement. This is what you get with the hosted or all the other options. And the new architecture is what you get in serverless. So how data was being managed in the traditional way is you have something writing your data, and it could be a language client like your Python, JavaScript, Java, whatever application is writing data, or you're ingesting some logs or observability data or security events. In any case, you have data and you send that to your cluster. What you have in your cluster is you always have, or for any high availability setup, you would have more than one instance of the data, because if one instance dies, the data needs to be held somewhere else. So you would have, for each document, since Elasticsearch is based on documents, for each document that you send, you will have a primary that is keeping the first copy basically, and then 0 to n replicas. Normally you would have 1 replica, so you store 2 copies of your data in total. So you write the data to the primary and the replica, and this is where you do all your writes and probably most of your reads. Let's assume this is a time series use case. So you have some data that comes in, like let's say logs, and the hot data is basically, let's say the data for today. It's where you do all your writes and where you do the majority of your reads, because you're mostly interested in like all the errors or warning messages that you have been getting in the last few hours or today maybe. So you write your data twice here, and you need to hold it twice. And what you then do is when you search your data, that's the other side, you use the searches, maybe with Kibana, maybe you just use the Elasticsearch API, but Kibana is the most common way to query your data. Kibana will then query your data from your hot tier. Since we have taken this time series data approach, once the data is written for today, there are no new writes coming into that segment of the data. And probably there are also going to be fewer searches, because you most likely look at the errors that are happening today, but you're less interested in the errors happening a few days ago. So in this architecture, what we're doing here is we're taking the data, we're moving it to the cold tier. The cold tier is basically more data per node, because there are no more writes, there will be fewer searches. And we also take a backup, or we call it a snapshot, to a blob store like S3. So we only need a single copy here anymore, because we have stored the data here in S3, the second copy. So we can get away with having a single copy of the data, whereas in hot, when we initially write the data, you have two copies. So we're down to one copy, and we can still search that. You can see Kibana still coming in here to search your data. And at some later point, maybe you reach a point after a few days, weeks, or months, when you know that you will access your data very infrequently. And it's kind of wasteful to keep all of the data on an actual node. So this is running on EC2. So you have EC2 nodes holding the data. Here you have two copies. Here you only have one copy, but you still have a node holding a copy of your data. And each node will be able to hold couple of terabytes of data, but once you reach a certain size, you will need more nodes, and that can get expensive. So what you then can do is that you can actually use what we call the frozen tier, is where we fetch data as needed from the blob store and just load it into that frozen node to make it accessible. That is for data that is infrequently accessed. And again, your searches will go again that frozen node, and if it needs to fetch data from the blob store, it will go down here. So as you can see, this works well, and this multi-tiered approach gives you cost savings, but it is also kind of messy, because your data has two copies and one, and your searches are all over the place, and then at some point you move it over to the blob store, and that all made sense in a classic architecture. But now with cloud native environments where everything has a blob store, we can actually move to a newer, more efficient data structure here. So looking at the serverless architecture, how this looks like is your writes are still coming in, but we have broken up that reading and that writing path, or indexing and searching, as we call it. So for indexing, how that works, rather than writing it twice, so if one copy dies, you still have a second copy you can fall back to. The write goes to the indexing tier, but will be immediately written to that transaction log on S3. And eventually also the final data structure will be written in an index store here on S3. So you only need a single copy, and there is no searching on this tier. So all the data gets written out here. And then you have a dedicated search tier that handles all the searches from that index data structure. The nice thing here is it is a much cleaner architecture. You don't need all of these tiers and everything talks to everything, but it's more nicely separated. The other nice attribute of this is that you can independently scale indexing and searching. So if you suddenly have a burst in write operations, you will just need to scale up that indexing tier to keep up with those write operations, but your search tier is unaffected by that. Whereas here, you read and write both from the same nodes, so you will need to scale up the same nodes and have a more complicated architecture. Also, the new architecture has much more intelligent auto-scaling, so it will do all of that for you, whereas here there is some auto-scaling, but there's also potentially some manual intervention required once you hit certain thresholds. Whereas in the new serverless architecture, it will just auto-scale that indexing tier to n nodes for you, and the same thing for the search tier. If you have a search-heavy use case, or you suddenly have a lot of people investigating something and you need more search power, you can increase this tier independently of the writing tier and just fetch the data and then make that accessible to your clients. So this is what the general architecture looks like, that we have broken up the reading and the writing, and the source of truth is always the blob store. And this allows us to get away with a single copy or instance of the data. We don't need the replicas anymore. And we can do much more auto-scaling and independence of indexing and writing. So this is the new architecture on a very, very high level. This looks very easy. There are a lot of changes needed under the hood to make this efficient, also because of the way that blob or the access patterns on blob stores work, where you pay per request, but also for data transfer. So that you need to have the right access pattern and rewrite the logic to some degree to fit this cloud native architecture much better than you did with the old architecture, where you were mostly relying on local disks, where the access patterns were just a bit different, or the trade-offs in latency and how often you write and how often you f-sync something are a bit different. But this new architecture gives us the new options to make this simpler, but also more efficient and scalable for you. Under the hood, and I don't want to dive too much into that, but under the hood, what we are doing is we're heavily building on Kubernetes. We have a blog post that is linked here at the bottom. And what we actually have is, right now we only have 4 regions, but we will build out a lot more regions over time. So we have that control plane that manages the projects. And that is one global control in Kubernetes. And then we break that down into the regions that actually run the different Kubernetes clusters on which your Elasticsearch clusters will then run. And you can see we could have more Kubernetes cluster than one per region, just because there is a certain size limit where things get complicated, or it also gets riskier because the blast radius gets larger, or just because of efficiency and scaling problems. So we have at least one regional Kubernetes cluster, but potentially more, that will host your infrastructure. And in the blog post, we go into a lot more details around like pushing updates versus pulling updates. So for example, here you write the global state, and then if that is pushed out or pulled out, and all of these considerations under the hood, as a user, it doesn't really affect you much. We will do all of this for you. But if you're thinking about building something similar, or you're just interested in more patterns around Kubernetes and how to run that with very large data architectures, the blog post gives you a good overview of how we're doing that. And we have also quite a few other blog posts. I will skip a bit over that. It's going too deep. But we have, I think, at least 7, 8 or so blog posts, and there are more coming about different parts of the architecture and how they work. So for example, how for search, the auto-scaling really works under the hood, or how the data safety in the stateless world is managed. So there are more or deeper description of the various hurdles you have to overcome and how we have implemented that. So if you just want to use the service, you don't need to really care about that. But if you're interested how it really works and what edge cases there are, or what trade-offs need to be made, the blog posts will give you a very good overview. And we have Search Labs as a place where we have a lot of interesting content around anything search. And it has this category for Elastic Cloud Serverless with all the content on that topic. So this is where you can get all the details behind the scenes. And I'll pause there for a moment if there are any questions. If not, let's move on. When will all of this happen? So we had in early early in this year, we had a private preview that was invite only. In May, we opened it to ungated, so anybody can sign up and do a trial on it. And we have free 14-day trials. It is going to be GA later. I can't reveal any timelines, but we're very actively working on that. And I want to say in the home stretch, we have been working on serverless for almost 2 years at this point. So we have invested a lot of work already, and we're very close to getting to that GA timeline. So you can already give it a try, and then soon we will be in that GA state. Though before reaching GA, and maybe even for some time after that, because not all the features will be available right away, there are some temporary limitations. And we actually have both temporary limitations and general limitations because of the nature of a serverless offering. So the temporary limitation I've already shown you, it's only AWS right now. It's only 4 regions. Initially, we launched the public preview with a single region. We've added 3 more. We're at 4 now. We'll add more regions and cloud providers over time. It's not a GA service yet. We do support. We have pages. People work very hard to keep this up, but it is not as battle tested as the hosted cloud service yet. Serverless will be for all workloads. As we're learning how it behaves, right now, probably small to medium workloads will be served best, just because we've had less experience with very, very large use cases. But this is a temporary limitation. Serverless will be the way forward for all workloads. And there are some pieces that are still in the works. So for example, we have in the works a managed intake service, cross-cluster search and replication. So replicating data between regions or searching across regions. Those are 2 very common use cases. Maybe for data privacy reasons, you need to keep your data in a specific region, or for high availability reasons, maybe if your entire AWS region goes down, you still want to have another copy of your data. Those will be supported, but we're not quite there yet. But those are things we're working on that will be coming. But there are also intentional limitations. There are a lot of operational APIs and features that we used to expose and that you had to tweak, and you can't anymore. And that is exactly why you actually want to use a serverless offering, because you don't have to worry about these anymore. You don't care about like, how many nodes do I have? How large are the nodes? How many shards do I have? How are the shards allocated? So basically a shard is like related data in Elasticsearch is stored in what we call an index, and an index is broken up into 1 or more shards. And that then has this primary and replica shard concept for the copies. You don't care about that anymore. You don't have to know anything. You also don't care about versions anymore. And this might be great, because I know a lot of people dread version upgrades. Some people might also get scared because you will automatically get the latest version, and serverless is just continuously rolling forward. So if you want to have very tight control over the version and exactly how things are working here, serverless will always be on latest if you want to or not. That is one of the things where you can figure out if serverless is the right thing for you. The other thing is, right now in the hosted cloud service, you have all the solutions in a single cluster, and you can mix and match any way you want. With serverless, we've made this intentional choice to have a more focused UI, to have a more straightforward onboarding, that we focus on one solution rather than giving you all the options. So you pick your path, but then you will have a much clearer path forward. Finally, while you can still use the Elasticsearch clients to interact with Elasticsearch that have always been available, they were built for the self-managed and hosted version. So they support all the APIs that might not be available in serverless anymore. And you might only figure that out at runtime when you try to call an API that is not there anymore, and you get a failure at runtime. There is a set of dedicated clients just for serverless that only support the features that are available on serverless. And they also have a bit of a different life cycle, because the serverless, the classic clients were always bound at least to the major version, if not the minor version. Whereas for serverless, you will also always want to keep those up to date and roll forward with the versionless approach. So you have the option of using those dedicated clients, but you don't have to. You can still use the classic clients and then switch between the classic hosted model and the serverless model if you want to. Just be aware that depending on what APIs you call, they might not be available anymore. So the traditional data APIs, like you store a document or you do a bulk operation to store many documents, you search a document or many documents. Those APIs are available everywhere. It's really more about those operational APIs that are not there, where you need to pay attention how to interact with that. Or maybe you were used to querying the /get endpoint in serverless, or sorry, in the hosted version, and then you got the version back, and then you knew which major version you had or what is the current version. While we still show you a version, it doesn't really make so much sense, or it doesn't mean what it used to mean. It's just more there for compatibility reasons. But serverless will always be on the latest version, no matter what the API might tell you. It is always the latest version. So these are intentional limitations, but these are basically the reasons why you would want to use serverless in the first place. The next question that's always coming up is like, how much does this cost? And this is more of a preview and how we are doing this today. Pricing is still being worked on very actively. Also to have smaller instance sizes. We started with that approach of like, we want you to have a very good experience with serverless. So we will give you reasonably large instances that will handle almost any workload and be able to auto scale with you. Though that will have its price, because depending on the approach you use, and we'll get into the different approaches, we have more optimized for that good experience initially than the lowest price. But we're tweaking that as we go along, and we're learning like how people are using that and what is reasonable, and also how aggressively we can kick in things like auto scaling. One of the fears, for example, that we have is that you might have a big spike and we might not be able to add new resources fast enough. That's why we will provision or over provision a little right now, just to have that extra headroom to make things safer. But we will tweak those. So pricing is just like more in the preview state of things. Diving into the details, each solution has its own pricing approach to some degree, which again is more of a feature. Previously, it was all the same and we couldn't differentiate. Now we can optimize the pricing a bit more, like how does it make sense for you, or how do you use the features of it. So for the security solution, we have two levels, like Essential has the essential set of features, and then Complete has more features. The other thing is we have basically two pricing dimensions. We have ingestion per gigabyte, and then we have retention per gigabyte per month. And these are the numbers. There are a few add-ons, for example, if you have anything like you want to have like a managed intake service, or sorry, no, not a managed intake service, but if you have the cloud security posture management and things like that, there are some add-ons for that, just based on the resources those will consume. But the base price model is really just ingestion and retention. Observability is very similar. It only has a single tier for each. Ingestion per gigabyte and retention per gigabyte. Things like synthetic monitoring, premium support, etc., are still on top. But otherwise, it is very straightforward. You know how much data you ingest in your cluster. You know how long you retain the data and how much you have it, and that will be your price point. Now, coming to search, search has slightly different trade-offs. Just because search is much more CPU intensive, both for the ingestion, but also the search and then the machine learning capabilities. So when I say machine learning capabilities, for example, you do inference. So you have a text and you want to have a dense or sparse vector representation of that. We can do that. But that is, of course, CPU heavy, and we will price for that. That's why we have this concept of a virtual CPU unit per hour. So you have that for ingestion, for search, for the machine learning capabilities like ingestion, and then the retention of the data, which is again gigabyte per month. You can see the size of the instances and what you get. We're also very transparent about like these are the instance types that you get under the hood and like what you really get. And we have 3 different tiers. As you've seen, we have general purpose, which is the general search use case. And then we have the vector search optimized version, because searching dense vectors especially has a bit different trade-offs in disk space, but it's more memory hungry than other use cases. That's why we have a different instance type here, and a slightly, I mean, the pricing is the same per VCU hour, but it's like different hardware under the hood. And then the upcoming time series optimized version has a slightly different pricing approach, just because how things are working out there in terms of ingestion and search. But this is the general pricing model again. This is what we have today. It's changing over time. This will still evolve a bit. As we learn and as we optimize our offering, these will take slightly different shapes over time. And with that, if there are no questions, we can actually take a quick look like where the instance that we started before ended up. So it was created in the meantime. Let's head over here. This is, no, this is the demo effect. Let me go back to Elastic Cloud. Here we go. Something timed out in the background. So this is for search, Elasticsearch, the UI. If you have used the Elastic Stack in the past, you will know that we had a lot more options on the left-hand side. We also didn't have quite this getting started experience. But this is, like I said, this picking the solution that you're going for allows us to give you a more targeted UI. So here I can say, I want to interact with all of this in curl, or I want to use Java. Let's stick to Java for now. And you can then say, I want to sync data and connect the client, or I want to just upload a file just to get started and try things out. It also shows you this is the serverless specific client. These are the dependencies that you need to copy to make this work. And you could just switch it out and say like, no, actually I want Python. And then it will tell you, this is what you need to add in Python to install all of this. It allows you to create a new API key. So we can give it a name, an API key. We can give it an expiration. You can then add like metadata. This is just like to make it easier to figure out afterwards, like who this was for or what application this was for. And you can also, for example, control what privileges you give it. It's luckily not as complex as I am in AWS, but you can define like what privileges do you have on which indices or which index patterns. You can make it read only, you can make it write only. So you can have fine-grained security here. Let's say we want to create this read-only API key. I don't want it to expire, and then you can just create that API key. And then you have the API key here that you can copy and use. It gives you the endpoint that you can then query. And then this is what you would need to add, for example, in your Python application to actually get started, to have the right input, to have the endpoint and the API key. So you really just need to copy this to get started. And then you have client info. It's just showing you what's happening. And then it gives you the next steps of where you can go from here to work with your data, to ingest data. It even gives you sample documents to go from here. You can pick where to put your data, and you could even run this right here in console. And that's probably the easiest way to actually get started, and I'll show you here. So for example, if we just fall back to plain curl, once you have curl and you have the endpoint, then you could export those and then you can run your curl commands. And you can then index your documents. But we can also just run this in console, and console is like curl, but it's running in Kibana, and you kind of like get rid of that pesky like the URL endpoint and the API key, because it will just know how this will look like. So I'll skip the tour here, but it basically takes the command that we've had here. It just takes out the curl headers more or less. And this console is available in all the steps now. So we can do a post, and then we'll index all the documents that we have here. So we have stored some data, and then, for example, you could just say get, and we have stored this in the index books, and I just say search my books, and you get books back. I didn't specify any filter rules or any sorting or anything, but this is the easiest way to get started. You can see how long the queries took, if they succeeded or failed. So for example, if I mistype, it would tell you what is going wrong. So this is really easy to get started. You could then even copy this out as a curl command. But what is very nice here, by the way, is you can write this in this easy syntax. It has syntax highlighting and auto completion. You can just experiment. And then you could say like, give me this command, but give me that as Python code. Then it will copy the Python code. I'll just paste this in here. Not that this makes a lot of sense, but you can try it again. Okay, you can just copy out the Python code and then just use that. Cool. You also have, like I said before, you have Discover, it figured out automatically what documents you had. You can build dashboards, you can manage your indexes, you can connect data. We have something called a playground where you can interact and include, for example, a large language model for RAG applications. You can build that. This is all included here, and you can just get started very quickly and build on that. The one thing that I wanted to show you still, I'll copy that out from the slides. If you have used Elasticsearch before, you will know these commands. So get / is just retrieving what Elasticsearch version you're running. And you can silently guess what will happen or what will work or what will not work. So if I run get / it will tell me that this is version 8.11, and this is a lie. It's not version 8.11, it's the latest state. It's just like when we created this API just to have some version in here, we called it 8.11, and we don't continuously update this one. It's just some applications are used to kind of like querying is what version number there is, and they trip up if there is no version number at all. But we haven't updated this one in a while, because we are currently at 8.15.2, which came out today. 8.16 will come soon, but we don't continuously update this version. Basically, when the build flavor says serverless, you're always on the latest version, and you can disregard this version number. The cat APIs are a bit like the cat API or the cat in a shell, where you just output information for human or in a human readable form. So what cat is, it will show you things that you can query. And this is a much, much shorter list than before, because previously you had cat nodes and charts and all of these, but those don't make much sense anymore, because nowadays, or with serverless, you don't care about all of that management. You care about your data. So for example, we can copy out this one here. And you can see we have our books index. Let me add the header so you can see what we actually have here. So it's the books index. It has a UUID. It has this many primary shards and replicas. We have 6 documents, we have non-deleted, this is how much storage you have taken. So you can see information about your data, but you can't necessarily get data about like what the infrastructure is under the hood here. So for example, if I would say, I want to say cat nodes, which existed in the previous versions, it says, well, this API is not available when running in serverless mode, because you really don't need to know or care about these anymore. So it's a reduced set, but it will make your life a lot easier. Storing a document, though, works just the same. So I have created my test index with foobar. I can search it. That is all good. One thing that you could do in the past that is now not available anymore is previously you could set the number of primary shards. But this, again, is one of these settings that is not available here. It's just like some management that we will take care of for you. So based on the solution and based on the amount of data you have, etc., we will make the right choices for you. And you don't need to worry about those pesky number of primary shards. People always got very confused. It's really more of an implementation detail that we try to take away that you don't need to worry about anymore. So hopefully, this makes it easier for everybody. But yeah, there are some changes to how this operates. And that's the very quick view of what serverless is doing. Are there any questions? Anybody wants to know anything, how things work in a specific way, what is available, what is not available? I can't really talk much about timelines and when specific features will be coming. But serverless is something we're working very actively towards. And there is still a lot of stuff coming, but it's already in a great place to get going. And you will have a much easier and more curated time to actually start this and get going. So I'll take this opportunity to take a sip of tea. Any questions?
I can join you here. Sometimes there's like a 10-second lag, so.
No rush, no rush. That's why I brought my tea, so everybody can think like, what have we just seen? How much sense did all of this make?
Let it soak in, yeah.
Yeah.
Yeah, if not, I can ask you some questions.
Yep.
Yeah, let's do that. And if anyone chimes in, we'll definitely ask it here. I was going to ask, what do you view as the competitors to this serverless offering? If you can answer that.
I mean, I think almost the biggest competitor is us ourselves with the hosted offering. And there will be use cases where you want to stick with the hosted offering, though many won't. Since we already said in the introduction, we're the original Elasticsearch, which means there is another offspring, and I don't want to comment too negatively on anyone, so I'll just leave it at that. So that is probably one of the big competitors here. And then because we have 3 different solutions, it really depends on the solution that you want to look at. But search, and especially vector search, is a very busy space. There is like lots of new vector databases popping up. Many of those also have serverless offering. And the same is true for observability and security. And I think for each one, you have your own set of competitors, but also your own set of how the ecosystem works. Because while the developers building a search application care more about the internals and they need to work more with the APIs. For example, for observability, maybe you don't really care so much that it's Elasticsearch under the hood and what an Elasticsearch API looks like, but you might care just more about like, oh, I want to use the Elastic observability solution and I want to throw my logs somewhere and be able to search them. And I want to see my traces and my metrics, but I don't really care like how many shards you have and how the data ages over time, etc. Just do the right thing for me. Because with competitors in that space, like if you're rich, you might use Datadog and you then might reconsider. But there you don't have to worry like how many nodes do you have? How large are the nodes? How many shards do I have? Do I need to rebalance anything? You just want to use the end product. And that's very much the same here, where we really want to just give you the solution, especially for observability and security, to use, rather than having to build that. But all three areas are definitely busy spaces. There are many players in the security world. Some take down airlines, etc., by a bad upgrade for a long time. But there are definitely many players in the space. Same for observability, and search now with Gen AI and RAG, the retrieval augmented generation, and vector databases like Elasticsearch, but also others. All of those are very busy, and everybody tries to have a serverless offering because most of us don't enjoy running services and manually picking versions and upgrading them or defining the infrastructure under the hood. Most of us just want to use what they are try to do what they did try to get done, rather than managing the underpinnings. But if that's your thing, you can totally do that. You can also run all of this still on-prem yourself. Many of us just probably don't want to anymore.
From like the inside, do you feel like there might have been like some lessons learned from like the original like on-prem version that like were adopted for the serverless flavor?
I mean, I feel like services really just evolve in like these generations almost. It's like they were the traditional relational databases, and they always had a hard time of scaling beyond one node. And then there was the NoSQL explosion that overcame that, but it was not built for the right cloud native environment because nobody was building on top of blob stores and how to optimize that. And then there's a new generation of tools coming in who was built from the scratch for that. So it's not like we could have anticipated that really or built for that. Like Elasticsearch started in 2010. So it couldn't have built in a serverless way or cloud native way back then. But in hindsight, there are of course many things where we're like, oh, had we known that we should or could build on these primitives, things would have been much easier or simpler. The other thing maybe for us to say is like, we are trying to use very much the standardized components that are out there so that we can focus on what we at Elastic do best. So we will rely on the blob stores of the cloud providers. We don't try to run our own blob stores. We will build on top of Kubernetes as an abstraction layer, just because we don't want to reinvent another layer of orchestration and reinvent the wheel there. So the lessons learned are definitely, there are a lot of tools that you can build on, and we'll try to make use of those building blocks, just that we can focus on what we are trying to do. Though also, Kubernetes is not an easy environment. There are multiple ways to do things. There are new tools coming in and old best practices going out. So there is still a lot of evolution and learning going on. And we're, by the way, happy to share those. So we often talk at KubeCon, for example, about like how we're building these services and what we have learned, which might be a different problem than if you just run your application there. But stateful applications like databases have a very specific set of requirements and trade-offs and pain points. And it's a very interesting world to see how everybody approaches that.
Yeah, it definitely, I mean, in my opinion, it feels like it's a challenging problem to solve. Like as a developer, it's like, oh, I would love my relational database to scale to 0, so I'm not charged for it. But like, then you have to think about what happens to your data. Like, yeah, this seems very similar to that.
Right, and how does it behave in a cold start? Like, if nothing is started, like, if you have a search on your website, most people will get pretty upset if your search doesn't respond like in a second or maybe 2, to be generous, or ideally less than a second. But if you need to spin up an instance and maybe load some data from S3, and all of that takes you 20 plus seconds, people will probably abandon your search. So you need to have the right approach for that. The same thing if you have like a burst of ingestion, the data needs to go somewhere. Either you have a buffering tier in front, or you need to be able to actually accept the data very quickly and move on. So it's potentially a bit of a different scenario. If you have the cold start for an AWS Lambda, for example, maybe you can work that a bit differently. but there is a very specific set of trade-offs for data stores, and what especially something that is near real time, like a search engine, needs to take into account.
I think I have 2 more questions, if you don't mind. I'm curious, this is kind of more of like an opinion, subjective question. What's the coolest thing that you've seen built with Elasticsearch that you can publicly share?
I mean, there are so many interesting use cases. I think one of the really cool things, it's already been there for a while, but in the Mars rovers, Elasticsearch was used in that monitoring and data collection for those. And it was always very cool to think about like our technology being connected to that. On GitHub, you also have this little badge for the Mars rovers. So if you contributed to Elasticsearch back then, you get that badge on GitHub. That's just one of many things. Though I think the other thing is, it's not necessarily only about like the coolest use cases, but more like the being useful day to day. And that's where Elasticsearch really shines, because it's the most widely used search engine out there. It's very widely used as the classic Elk stacker for observability. So this day-to-day use and actually bringing value, I think, is what generally excites me rather than just the shiniest use case.
Yeah, I mean, honestly, for a lot of people, like it's boring, but like if your underlying like core technology, like even like an S3 is not working, like nothing works. So it's stuff we take for granted for sure.
Yeah, I mean, that is kind of like an interesting pattern, by the way. I think that while S3 is not an official standard in any way, everybody adjusted to it, and everybody has an S3 compatible API. So we also learned the hard lesson that everybody calls or says that they are S3 compatible. That doesn't necessarily mean that it behaves exactly the same, and you might run into weird edge cases. It also means that depending on how you access it, that different access patterns work better on different blob stores. So the implementation for Amazon, for us, will not be exactly the same as it is on GCP or Azure, just because like how the services are working in the background gives you different trade-offs in terms of caching and data locality and scaling up and down. So you need to take those into account. But it is fascinating that something that was not a specification or a standard at all established itself more or less as the default way to store data nowadays.
Yeah, I totally agree with that. Last question. What's the best way for folks to get in touch with you if they want to follow up?
Yes, so that is actually one that I always try to explain. So my last name is Krenn, Krenn. And if you rotate the letters by 13, you get the handle XERAA or Xera. That is my handle everywhere. So it's my last name, and you rotate the letters by 13, and that's what you get out. The nice thing about this, and it's like ROT13 is this classical thing that I think 20 plus years ago was often used. Like you had the spoiler to a movie, and you didn't want anybody to accidentally read it. You would ROT13 encrypt it. The good thing about ROT13 is like encryption and decryption is the same, because you rotate by 13 again and you're back at the original. So that's where this is coming from. And I think I made this up back in school already when I was on some public transportation or whatever. And I just like basically took my last name and rotated the letters, and I saw that this is kind of legible. And since then I have been sticking to that. So you can find me on Twitter and on Mastodon and GitHub, pretty much everywhere under this Xera handle. It's pretty unique, but it's also very much tied to me. So that is the background story of why I have this handle, and it's not related to Xena or anything like that. It's just kind of similar, but it's also pretty unique. And there are not a lot of handles that start with X, so it also has a bit of that uniqueness factor to it, which is a nice bonus.
Awesome. Well, thanks so much for sharing your knowledge with us. I don't think I see any more questions, so I'm not gonna. Let's
hope everything is clear. Yeah, if folks have any questions, reach out to us. We're always happy to to engage. We have a community Slack, we have a Discuss forum. We're pretty active on social media. So if you shout, we'll normally see it and then try to help you.
That's exciting. Yeah, awesome. I've just got 2 more quick announcements before I end here. Reminder that on Friday, we have another live stream. This is going to be with Alan Helton and Michael Liendo. They're going to be getting live reactions on any web page. So that should be a fun live coding session. And trying to think what my other one was. Oh yeah, my other announcement was if you're not already in our Discord server, feel free to join us. It's believinserverless.com, and there should be like a Discord invite link there. So we can continue the conversation there as well if you just found us on YouTube or something. So everyone's welcome. But yeah, aside from that, I think I'm going to end the stream. Thanks so much for joining us, Philip.
Thanks for having me.